I'm Joseph Nelson. I'm the co-founder and CEO at Roboflow. Um, our headquarters is Des Moines, though we are a remote distributed team. So we have employees from Oregon to DC. Um, and what Roboflow does is we build developer tools that enable teams to use computer vision without hiring a team of machine learning experts. So I think actually it might be useful to talk about independent of Roboflow, like what is computer vision and why are we dedicating our lives to working on this problem? So computer vision is a machine learning technology that enables our software to see as good as, if not better than people can. It's the same technology that you might be familiar if you like deposit a check via using, a bank giving a bank app. Maybe you've heard about technologies where doctors are enhancing their ability to diagnose skin cancers through machines that improve those sorts of technologies. Self-driving cars are kind of like the marquee example of computer vision where the car is now able to interact with the environment independent of a driver. And our thesis is that computer vision is going to be used by every single company, similar to the internet, similar to the personal PC, but not every company is going to need to hire a team of computer vision engineers to get there. In the same way, not every company needs to hire a team of network engineers or even set up their own data centers. And so if we can provide the infrastructure for teams and companies to use computer vision in their products, then we can accelerate this technology's impact on our world. And I mean, thinking about one level higher for a moment, like the reason we think computer vision in particular is such a important piece of technology is it actually shifts the way in which human computer interaction happens. So think about it like this, like right now, let's say that you're driving your vehicle and you have Google Maps up on your vehicle that's giving you turn by turn directions. What you are doing is you're receiving input from software in the form of Google Maps, and then you are processing that information and then providing the inputs of that information turn by turn, how to stay in the lane to another piece of hardware software mix, which is your car. And in the future, actually, I mean, in the present, in some places, you can actually change that relationship where if software can see and understand the world independent of the human, you actually make it such that software communicates more effectively and more accurately with another piece of software. And then the human is either just a corrective force, if not someone that interacts with the environment in an enriched way, right? That's like the doctor example who reviews cancer diagnoses that might be more accurate rather than a doctor who might be more susceptible to air or things like this. And so, in other words, we think that this sort of change in the relationship of how we interact with the world around us is inevitable. And the starting point for us making that transition easier is building the tools so that companies can use computer vision in their products. So we build the tools for developers to use computer vision, which involves things like collecting your images, labeling them so a computer can understand where the objects are and what the objects are in those images, training machine learning models and neural networks to understand what those objects are, how they're moving across the screen, and things like that. And deploying those models, meaning you can actually use them either on like your mobile phone or maybe in an embedded use case, like in a fields, anywhere that a model might be adding value, whether it's a factory or a consumer application, allowing people to use their models in that way. So that's kind of like the um, bigger picture idea of what we're working on. Now we've actually had pretty good traction with that. So in the last, a little under a year and a half since the product has been available, a little over 30,000 developers have used our tooling to apply computer vision to their industry. And frankly, this is something where like, as a founder, it's like, we start this company with, it's almost like a religion where you're like, computer vision is going to be everywhere. And it's just sort of like, you're like the crazy guy where it's like, oh yeah, okay, sure, sure, sure. But now that we've seen the technology and product be available, it truly has been remarkable in all the ways that really the upper bound is people's creativity to using vision for their industry. So everything from like identifying gas leaks, we have a Fortune 50 oil and gas company that looks at security camera footage to identify when a leak is happening, to we've had students build things like sushi identifiers, like take a photo of a piece of sushi, tell me what ingredients are in this, to logo identification and retail use cases, measuring fish at fish competitions, Of course, self-driving car use cases we've spoken about and traffic identification. Really, it's hard to think of an industry that's not going to benefit from the value that computer vision offers. And so our thesis is making that easier in the form of the tools to make this be brought to production allows the future that we all want to live in to happen more quickly. And I have like some visual examples of this. So I mentioned that Fortune 50 oil and gas company. Here's like an example image of what that might look like of identifying leaks and sending a notification. On the right-hand side, you can see an example of like a large manufacturer that's taking x-rays of refurbished phones, and they're identifying if there's anomalies or counterfeit batteries or missing screws. If you look really closely in the bottom part of that image, you'll see those like completely white holes. There's supposed to be screws there, right? And so a computer being able to quickly identify and alert those that are on the assembly line that there's an issue reduces the error rate and increases the productivity and development of these given products and goods. And a few others. We've had researchers in the healthcare space accelerate cancer research in terms of identifying, in this case, they were looking for neutrophils and the reaction to a given protein based on given treatments. And on the right-hand side, you can see that we've had customers do things with pill counting and pill detection. Actually, a Telefarm in Iowa City is the customer that has been doing that in their use cases. And now, of course, that they've been acquired by Cardinal Health within Cardinal Health more broadly. So there's a couple of examples that hopefully, bring this abstract concept to life. And I guess maybe the only other thing to provide a level of introduction to is that's kind of the product and the vision and the company and the technology. I can talk a little bit about, as a company, where we are at. So as I mentioned, Roboflow as a product has been available for just under 18 months. As a company, we are 8 full-time employees. We did a startup accelerator program called Y Combinator last summer. And then we raised about a $3 million seed round shortly after that from investors like David Sachs, who is the COO at PayPal, and Lockie Groom, who was one of the first 100 employees at a developer company called Stripe for payment processing. And now we're to the point where we have a lot of conviction that we need to grow the team faster. So one of the reasons I'm here today is kind of express the desire to grow the tech ecosystem within Iowa and beyond. And presently we have openings for designers, those on the sales team, and for engineers. We also sort of have like this wild card position, which is like, let's say you're someone that's really talented and really excited about the mission that we're working on, but you don't see a role that explicitly speaks to your skill set. We welcome you to apply anyway, right? We are going to be growing a lot in the next decade. So it's important to us that top talent can raise their hand and say, hey, I want to be a part of this, even if you don't have something for me exactly today. A lot of the time, a startup's mission is to vacuum up all the top talent that it can anyway. So would love to hear from you on that end. And that's all available, of course, at roboflow.com/careers. So that's an overview to the space. I can, of course, open it up here for questions and dive deeper into any of those specific elements.
Hey, this is Matt. Great presentation. Thank you. One of the things I was struck by, because I know a friend of mine who's a pathologist, right, and in many ways how the traditional pathologist role is already rapidly changing, to your point, and just a new book out from Daniel Kahneman and a few other writers on noise. Have you heard about the book Noise?
I don't know noise. I know Thinking Fast and Slow, but not noise.
Yep. Yeah. So Kahneman and a few others started to investigate the two things that really negatively impact human decision making is bias and noise, and the feeling that noise is just kind of receives second chair to bias. But a lot of what they're is where humans, given the same conditions or same parameters, different times where human error kicks in. So just thinking about what you're doing, just a strong case for also the areas where we can eliminate human error. And so some of what they talk about in noise is similar crimes, but judges, depending on even the weather, if it was poor weather, they delivered harsher sentences. They talk about doctors at the end of the day being tired and not giving as good of a diagnosis. So some of those things where the tradition for me is let the humans do the human work and let the computers do the shit work, right? But this is where the computer is not going to get fatigued. Computer shouldn't be upset about the weather, right? Could be negatively impacted visually by weather conditions, but so just thought that might be another case as you're selling where things are going as you have a Nobel economist on your side.
I mean, one thing that that touches on, which is incredibly important, is these models are only as good as the data they're trained on. And
Right.
so let's say that you had a bunch of those doctors whom it's the end of their shift or the end of their day, and you're asking them to identify glioblastomas or whatever the use case is.
Yeah.
If you're codifying poor data, the model, of course, is only going to be as good as what it's been shown. In
Right.
a lot of ways, the way I like to anthropomorphize models in AI generally is it's kind of like teaching a toddler to learn. And if you teach a toddler that you should put the square thing through the round hole, that's what they're going to think they're supposed to do, right? And so if you don't have good training data or you don't have good flashcards, you can't expect the models to do better. And so that's where you get into conversations around the importance of both having representative data for the thing that you want to identify. And kind of the good news there is the ethics and the business case overlap in a positive direction in that
Yep.
for the same reason you want to have a data set that's representative of, say, the population you're trying to understand, you also want to, for all sorts of important moral implications, that's also good business. You want your model to be able to work for a wide array of populations. You want to
Yeah.
advertise that it can work as desired. And so I think that's actually something that's convenient about the when we think about data set aggregation. And then kind of the other note that I think about as it relates to like benchmarking model performance and data set aggregation and model and moral ethics is, of course, like all things, artificial intelligence is a tool similar to a hammer is a tool, hedge cutting is a tool, and those tools can be used for the purposes that the user intended, or they could be used in malicious ways. And so when I think about the ways to ensure that it's used in um, positive ways, it's both in terms of ensuring that the use case has been well thought out and the data is representative. But also, what's kind of unique is when we think about bias as it exists in human decision making, it's not as rigorously measured as it is in the case of AI. And by that, I mean, you can set up a survey and see. I mean, there's been studies about, you remove someone's name from a resume and people's decision making about giving that person an interview differ. Um,
Right.
and you can run those studies. What's interesting is that when you use artificial intelligence for a similar task, there's by default a measure, right? There's by default a metric associated with the performance, which to me actually provides a lot of optimism for reducing bias in our systems, because it's kind of like we either live in a world where there's humans where we have to set up experiments and identify bias and then like be able to condemn it, or we use AI systems which by default are measured and we can provide a benchmark and provide a place for improvement. Uh, and so that's when I think about
Yep.
these sorts of data set construction, model measurement, ethics. I think that in fact, like the comments about biased AI um, is actually something where we're able to benchmark where bias exists because we're codifying human decision making and improve upon it. And so it seems like a really good opportunity.
Right. And the bias that's in the system is just it's the bias from the developer, right? And you can
Exactly.
measure, but
Exactly.
and I loved your notion about learning because those were some of the things that right at Amazon when they were looking at people that they hired, right? And well, if you point a system at, in this case, a racist system, it's going to learn racist tendencies, and not that it's doing it ill will or maliciously. It's just we were taught these are good resumes, right? And so it's like that's one of my other feelings too with technology is it for good or bad it can accelerate, right? So if there's errors in the system it just helps you screw up faster, right? But having those level sets, and I really do appreciate you explicitly talking about the ethics though.
Yeah, I mean, in a lot of ways, my succinct way of thinking about this is AI decision making is a mirror of human decision making based on the data it's been fed. And sometimes we don't like what we see in the mirror, but at
Right.
least we now have a measure of baseline to improve.
Right.
So I think, yeah, that's kind of the way I like to think about
Cool. Thanks.
I had a question. But first, I guess I just want to clarify. So the monitor or the diagnosing tool, would you use that alongside with the clinician diagnosing, or would you use the tool and then just kind of go off of that to treat the patient?
it. The use cases will be highly dependent upon what objective is meant to be accomplished and the benchmarks for when a system can operate autonomously. In most cases, the way these systems are deployed initially is they're deployed both in tandem with doctor decision making, because that allows both like live quality assurance of how the model is doing. So if a doctor either validates that diagnosis was correct or invalidates it as incorrect, that's a really useful another piece of training data for the system to improve. Now, there are some cases where, actually in dermatology specifically, we've seen this, that models exceed even the world's expert dermatologists. And all doctors aren't created equal either, right? So if you create like a system that works from the best dermatologists in the world, and then you provide that technology to every dermatologist in the world, well, now the average diagnosis is not just what the doctor average is, it's based on what the top performer is. Now, as is the case with the conversation we were just having, the bar for deployment for autonomous diagnosis is rightfully higher in fields like medicine, where it's literally life death type decision making. Um, and that's not the case in all fields. Like if you contrast that with manufacturing and quality assurance, for example, it's much more a question of, okay, we're going to have to use human quality assurance for some amount. And every amount that we can rely on the model is a percentage decrease in cost efficacy. In other words, a model that's like 20% accurate, and we know the cases where it's inaccurate, means that we can be 20% more efficient with the way we allocate our other resources. Whereas in medicine, it might be much more that we have higher thresholds. The model needs to be 99 or 99.5, or compared to the null doctor hypothesis, it needs to exceed that. So long story short, the most time these systems are deployed, especially in cases where there's life death situations, it's in tandem. Over time, some of these systems do get to a point where they exceed even the best doctor performance.
Yeah, because I guess the only thing I was wondering was, say like the tool diagnoses a specific disease, and if it's not that, like it would kind of narrow the scope of a clinician trying to diagnose it, because they'd be stuck on, oh well, kind of like this tool told me that it's X, Y, and Z, and so they're just focused on relating all the symptoms to that disease instead of figuring out where what it might be otherwise. So I think that was just kind of something I was um, concerned about or just questioning.
Definitely. Definitely. Yeah, it's often one input in a broader picture.
All right, thank you.
Hey Matt, I'm Holly. I'm actually working on a startup that's using computer vision for weed detection, so I'm really interested in your product. I was wondering how Roboflow compares to existing tools like OpenCV or MATLab's computer vision toolbox.
Yeah, that's awesome. I'd love to help support you build that product. We work in tandem with a lot of existing tools. In fact, like as developers ourselves, it's kind of core to our ethos that interoperability, ease of use, and whichever tool you want to use for the respective part of the tool chain, you're able to use that tool for the job. You mentioned OpenCV specifically. We're actually partners with OpenCV because we do quite a bit of work together. And OpenCV is the world's foremost popular library for computer vision, downloaded about 1 million times a week. And so it's been around for about 20 years. It was open sourced originally by Intel. Now, OpenCV, as you know, is a lot of fundamentals of image processing and not a lot yet in the realm of deep learning and neural network and machine learning based image processing. So there's a lot of complementary ways to do those things together, right? So for example, like we have a customer that does they allow people to play Magic the Gathering in remote settings. So like imagine you have a camera pointed just down at your desktop, and they use computer vision to identify where the cards are that are in play. And then they'll use OpenCV once they have the card in frame for doing deskewing, right? Because that's more of a rule-based algorithm rather than machine learning-based algorithm. So a lot of the times, these tools are complementary in nature. The other tool you called out explicitly was MATLAB. MATLAB, as you know, is academic licensed and kind of pay to play. Roboflow is totally free to get started. We think that's really important. And a lot of the times for something that we have as a tool chain is we are kind of every step along the process. So you might still, even if you're using MATLAB, you're probably still going to need a place to collect your images, organize them, annotate them, share them with your team. And then even if you're doing your model building in MATLAB, you're still going to want that part of the tool chain, right? So that's kind of the ways in which we exist in parallel and in tandem with a lot of these tools and technologies.
Okay, thank you. And then something I wanted to ask about more, you mentioned that you've got a lot of integrations. Can you talk about those integrations? So like, I'm using a lot of like robotic operating system in mind and trying to integrate between computer vision algorithms like that.
Yeah, all kinds of stuff. I mean, I'd love to talk about your specific use case one-to-one when and talk about the specific nuances of it. But like one example is once you have let's say you're deploying to we'll say like a NVIDIA Jetson, right? If you're deploying to NVIDIA Jetson, being able to use your model in tandem with the rest of your systems and tools is essential. And so what we do is if you train a model with Roboflow, you can then grab the Docker container that contains all the dependencies and the model and its weights, and then run that on your Jetson. And then you use the model in tandem with, you've passed it an image or a video feed, and you receive back detections. We've had plenty of customers do things with robotics. Like I was just sent a video last week of a customer that built one that identifies where ball bearings are and then like sorts them accordingly and correctly. And so like a core part of our ethos is that like this ecosystem has lots of great tools. If we can enable people to choose the best tool for the job for their respective process, then that's better for all involved. Rather than saying that like you have to only use one thing, I think that it's both better for a developer experience and therefore better for our company and the user.
Sweet, thank you so much.
Yeah.
Yeah, so kind of going off the machine learning, so you're getting all these different types of data sets coming in. You've got like pipe leaks and ball bearings and all these different things. So does this, as you get all this data going through your system, is that helping to train the system itself, or how does that work? Explain it to me like I'm 5.
Yeah. It's a good question, and it's one of the benefits of machine learning is that like the more data you have, generally the more you can improve your system. One tactical note, the way that Roboflow is structured is when a user uploads their data, it's still private and unique to their account.
Sure.
So for example, in the context of the oil leaks problem, I can't go and grab this Fortune 50 business's data and share it with other Fortune 50 businesses' data.
Right.
Now that said, as they collect more and more data of their context, their system can and will continue to improve. And a lot of the times in machine learning and computer vision specifically, the way that you're writing code and programming is you are collecting examples, and then machine learning is writing the rules that connects those examples, which is different than traditional programming, right? Like traditional programming is we write the rules and we hope that produces the outputs we have in mind. Machine learning kind of flips that on its head and says, if you show examples, then a machine will learn the way to map those examples one to another. And Andre Karpathy, who leads vision at Tesla, has a blog post called Software 2.0, which explains this in a much more elegant and great sounding way than I have here, that I certainly welcome to think about this shift in paradigm. But in doing that, the way of building successful, robust models really does depend on surfacing edge cases and surfacing places where you think your model will fail. In other words, it's pretty, I'm not gonna say pretty easy, it's dependent on the domain, but it's easier to get to like a model that performs at a level you might deem acceptable for the most common use case, right? We'll say in the pipeline example, a leak that happens in a well-lit, noon, at one location where you have a lot of data. But then let's say it's like foggy or it's rainy or it's misty, and the leak is in a different spot on the pipeline. And that's just a less represented condition. The model is going to struggle more on those examples, which means collecting those failure cases is essential to overall model improvement. And so your head is exactly in the right spot when you're asking, how do we continue to improve the model over time? And the term for this is called active learning.
Sure.
And so if you can architect your system in a way where you're not just building a model once and then like setting it and forgetting it. In fact, you're building an initial model and then trying to preempt and identify the places where it's going to fail and continue to incorporate those into the systems for quick redeployment. And so one of the things that we're pretty focused on is how do you build the tooling to surface those examples and to quickly retrain and redeploy so that the decision is very simple to go from, okay, I have my first model working in production. I can prove that this isn't fake science. This works. And there's going to be future cases I'm going to want to identify to redeploy. And the faster you can make that feedback loop, the more successful the customer is going to be.
Nice. Thank you. Any other questions?
Yeah, hi Joseph, this is Eric. I have a very tactical question, application. We are a startup in trucking logistics. We're identifying warehouses. We have access to a large number of satellite photos and we need to identify the edges of the building, which I think is probably, maybe a challenge, but not too challenging. But we'd also like to identify the edges of what's called the yard. That is the areas where the trucks actually go. Two things. One, I think maybe we could have an offline discussion and dig into a little bit deeper. But for the group, can you talk about how you might approach that, or if somebody has an idea like that, what maybe the steps they might take to use a product like yours?
Yeah. I appreciate that. I think the question of how do I structure the problem statement and like what steps should I expect is a really good general process to discuss. So I'm happy to walk into that. And then I'm also happy, Eric, to talk separately about applying this specifically to the domain problem you described. So the first thing that's like principally important when you're thinking about, okay, how do I use this vision technology is having a well-defined problem statement in the form of what it is you want to detect and identify. And so this is similar to like going back to the toddler example of like, if you think about your system as a toddler, providing really explicit instruction of what you expect to provide and what you expect to get out from the vision system is critical. In the example you provided, you did a good job of describing, I'm interested in the edges of the yard or the edges of the warehouse and the edges of the yard. And so we have that. We have a hook of what the model should do. The second thing to think about is what level of relative success we want to get to initially with what we were just talking about in mind, which is the model's not going to be perfect and we shouldn't expect it to be perfect to be able to start to get value from it. So what is the level where we can start to say, we're going to get value from this thing? It's going to save us on operating expenses and we can expect it to only get better over time. And so that will depend on the domain. We talked about healthcare where that barrier might be higher. We talked about manufacturing where it could be more in the middle. And then in operational use cases, actually the bar is usually pretty low because any level of improvement means that you're optimizing labor in a lot of cases. And then with those two things in mind, it's like, okay, great. I have a problem statement and I have an idea of what I need for success. Then it becomes, okay, can I collect a bunch of images that represent the conditions of interest? And so in your case, it sounds like satellite imagery of these warehouses. The natural next question is, okay, how many images do I need? And this becomes largely a function of how varied the thing that you're trying to detect is. So by varied, I mean, if you're trying to, we'll say, track a soccer ball across a bunch of different stadiums and a bunch of different arenas and a bunch of different lighting conditions, that's a more challenging problem because the context is changing pretty frequently compared to perhaps an example I showed where we're trying to find missing screws in an X-ray image. And you can think about it like there's broadly a relationship there where the more complexity and variance, really, the more variance there is in the situation, the higher your image needs will be. Now, in terms of like applying numbers to that, you could get value from a model as few as a couple hundred images. In the case of like counting pills, this could be the case. Or in more complex unstructured use cases, you could find you're in the hundreds of thousands of images. But for your tactical problem of rooftops, let's say we initially grab 1,000 images of satellite images of warehouses. The next thing we would need to do is actually like label, meaning like tell the model what we want it to know about these images. In your case of finding the edges of the warehouse, we would maybe want to call or draw what's called like bounding boxes, which is just as it sounds, like basically say which part of the image, put a box around it that you're interested in the model learning. And we would do that for, say, 500 of our images. We would then train a model on those examples. And we can do some tips and tricks, by the way, to turn those source images, those original images, into a bigger data set. Like we could almost apply like a bunch of Instagram filters to randomly increase or decrease the brightness on those images, or like in the case of satellite images, if you like randomly rotate them, because from above, it could be from any orientation, you kind of like create ways of artificially increasing the size and representation of your data set for your model training. And then once you have your model trained, we'll assess, we'll take stock. We'll say, how close did this get to our desired level where we said we were going to get value? Do we want to collect and label additional data, or is this something we can take to production? In the case of taking it to production, we might want to think about where do we want the model to run? So in your use case, it sounds like we could probably have the model run perhaps on a remote server. You pass satellite images to that remote server, and the server sends back, hey, I found the edges of a warehouse here. You might have other cases where you run the model, like for example, if you're in agriculture, you might be running it out in the fields in an internet disconnected environment, which has a different set of considerations. And then the last piece there is making sure you have a way to continue to collect data so that you can continue to improve this system overall, to our conversation previously. So hopefully that's a nice, like in-depth, step-by-step approach that a lot of these problems walk through. And while that sounds like a lot of things to do, the kind of remarkable thing is that a lot of our customers whom already have some data collected go through this process in a day. And they have an initial model they can start to take stock on and say, how is this going to look? Can I take this to production? What are additional images that I might need to collect for improvement?
Yeah, that's great, very helpful. And we will have offline discussion or follow-up. And one of the things I like is your example of Tyler. I use, when I talk about what I do and try to explain a lot of this, I like how it is very much like a human. The way you're describing it is, if I was going to give this to an intern, the process is very similar. I give them a stack of a few hundred images and say, find the edges here, and then we'll learn how you learned that, so you could go on and take one that we just pull off randomly and identify the same thing. So very nice. Looking forward to following up with you. Thanks.
Yeah, I mean, you know what AI stands for, right? Army of interns, right?
Yeah.
So that's the that's kind of the heuristic that you can think about.
Right.
I do want to switch the focus a little bit, talk about Y Combinator a little bit. We've got a bunch of students that are going through the Hawkeye Student Accelerator, which, there's a process to get into that, but Y Combinator is one of those things, it's one of the top, if not the top accelerator to get into for startups. Tell me about your experience with that, applying, being there, and then what your takeaways were from that experience.
Yeah, happy to. Roboflow wouldn't work as well as it does right now if we hadn't done Y Combinator. So it's comes as a highly recommended program. Let me talk a bit about our application journey, the program itself, and kind of like life after Y Combinator, often abbreviated YC. So we applied to Y Combinator twice. The first time we applied, we didn't even get an interview. We were building our own computer vision applications for making board games more fun to play. And we'd actually built a lot of successful applications. If you see, like Brad has joined the conversation. Mm-hmm. Before Roboflow as a company, we had worked on something called Magic Sudoku, which is like a Sudoku puzzle solver, and actually won Product Hunt AR App of the Year, right? And so that's kind of what gave us our hook into thinking about building computer vision apps. We applied to Y Combinator with the vision of making board games more fun to play as a stepping stone to this broader vision that I described at the beginning of our conversation, which is adding software features to board games is just like an inkling of the bigger picture. We can add software features to any physical object, right? And then the second time we applied, by that time the company had determined that the most effective way to accomplish our goal is actually to build the tools so people can build systems that interact with the real world. And that's the batch where we had an interview and we joined the summer 2020 batch. In terms of like the kind of like tips and things that I think come from that part is persistence. It's very common that a lot of companies apply more than once before they're admitted. And then secondly, I think in an application, one of the most important things is just like very clearly describing what you're doing. I think our first application perhaps made it sound a bit unclear of were we doing this board game thing or were we doing the developer tooling thing? And our second application was very crisp and concise. We're doing this tooling thing. Now, of course, this is just me trying to counterfactual reason about the differences, but I do think that is relevant. The interview process is, there's one interview, it's 10 minutes. It was Brad, my co-founder, and I in a room with, I think there were 5 YC folks on the other side, and it's known for being kind of like a rapid fire kind of discussion. And we came out of the interview, we're like, oh man, we bombed it. Like couldn't have gone well. And then we got a call later that night offering acceptance, and we talked it over and thought it'd be a good thing to do. The summer 2020 batch ran from June to August of last year. It was the first batch that YC ran that was fully remote. So whereas for YC, you would typically move to the Bay Area for 3 months and complete the program, we were the first time they said, actually, no. I mean, of course, in response to the COVID-19 pandemic, but I think will probably keep it that way indefinitely, given how it's allowed them to admit international companies. It removes a requirement for companies to be able to get funded. It's allowed them to scale the size of their impact a bit bigger. A lot of the things that you hear about remote. And in the remote batch, what's kind of unique about YC is a few things. One is it's a forcing function for what you're going to do within the three-month period. So the program culminates in a demo day, and you set a demo day goal early on in the batch, and you do everything you can to make that demo day goal become reality. And startups often are a lot of times like saying no to things that are good ideas, only to focus on the things that are like great ideas, right? It's sort of like what a lot of people say. And in this case, like it's saying no to everything except things that are going to help you hit your goal. And so that forcing function and having both the support of fellow companies and experienced entrepreneurs is really, really helpful. The second thing I think that is pretty unique in the program is how experienced YC is at running fundraising processes. And so for companies, a lot of times if you're going to raise capital, even if you start a number of companies, maybe in your lifetime, you're going to, fund 5, maybe 6, right? Like at the top end, like even Travis Kalanick, I don't know if he's even had like 6 venture-backed companies. And investors, that's what they're going to do day in and day out. And so there's sort of this imbalance of like how to approach a fundraising process for if you're a company and you kind of get these, very few number of at-bats. Whereas if you're an investor, this is like what you do professionally, and there's just a very regimented way to think about it. And so YC kind of helps tilt that balance back in the favor of founders in terms of here's the way to think about fundraising processes, here's the ways to think about approaching investors, and then also here's connections through the process that is demo day itself, where hundreds of investors attend and listen to the presentations of these companies. And so that was extremely helpful for us to attract a great cast of backers that we've been able to attract. And then the one thing that I should have mentioned is, so because it was remote, we did YC from Des Moines. And so we lived and rented a house on University near 42nd Street, if you're familiar. And the Brad even like moved out from like him and his wife's house like into this like startup house. We had one of our early employees living with us there too. I'll send an article for you. Kate Hayden from the Business Record wrote a bit about like Roboflow's like smart house or whatever it was. It's kind of a fun article of what the environment was like. But that kind of speaks to like both the forcing function and for us, how we felt we were able to get the best of both worlds. And by that, I mean like we were able to have the focus of like the Iowa ecosystem and the closeness and connectedness, but having the a lot of venture capital exists in San Francisco and New York and some of these other places. And so being able to attract the ambition, valuations, and investors that, I don't know, it's really kind of the best of both worlds in a lot of ways. I think we got lucky in that regard. And yeah, the last thing, of course, is just being able to connect with other companies in the batch. There's nothing like talking to other founders that are facing similar problems. Like this customer said no, or like this product isn't working, or even like other companies in the batch using your product and becoming early customers. Those are all like really useful things that kind of happen from YC. So that's like during the program and what was helpful for. Post YC, we still very actively engage the YC community. All of our job listings are posted on their jobs forum, which is called Work at a Startup, very creatively named. And so by hiring through the YC network, we, I think, attract, just kind of a different caliber of individual who's aware of the ambition and goals of YC companies. And it just helps with bringing people into listings. So you're not, it's less shouting into the void and more people are aware of the YC network. So companies that are hiring via the YC network might be more likely to attract talent they're eager to work with. And we still talk to our YC partners as well as we think about some of the next strategies and things we're doing as a business.
Very cool. Very cool. Anyone have any follow-up questions to that?
So you're selling your expertise. This is Paul Heath. Do you have any products of your own that you're going to package in the future and sell?
All of Roboflow is a product. It's a software as a service set of tools that customers use. So while as the founders, we certainly aim to like exercise our expertise on a lot of these types of questions and problem, the product is entirely self-serve. We wouldn't have been able to, attract 30,000 developers by individually talking to every single person necessarily. And so the product is a subscription-based tool that developers and teams use for creating models custom to whatever problem they want to solve.
So I want to, as we are getting closer to the end here, I want to talk about paint.wtf. Tell me a little bit about this, because this is a really interesting. I've just been feel like I'm on the periphery, just kind of watching as this unfolds. Tell me a little bit about that and how that's an extension of Roboflow.
Sure. At Roboflow, we enjoy trying out new technologies. And kind of like hackathon style building stuff. Paint.wtf, what it is a game that you can visit it right now, https paint.wtf in your browser, and you'll see a series of prompts. And those prompts are actually generated by AI. And so the prompt will say something like, draw an upside down dinosaur or draw a giraffe in the Arctic. So you'll draw it, and then the drawing gets scored and ranked, and then you can see how you performed globally. And the other secret there is the ranking is also done by AI. So you sort of have this like AI sandwich where like a prompt is generated by a text generative bot. A user draws what they are trying to draw, and then another AI ranks what that drawing looks like. Okay. Now, what does this have to do with Roboflow? Arguably nothing. We wanted to try out a series of new models that had come out. One specific technology that came out was called Clip, which is an innovation that is a computer vision model that knows a lot about what the content of images already contains without you needing to provide a bunch of images. So recall in Eric and I's conversation, one of the steps I mentioned for identifying the edges of warehouses is I said, okay, make sure you bring your images, and then we'll train up a model. One of the innovations of this new piece of technology that came out in January was perhaps you don't need to bring your own images, and a well-trained existing model can just already know things about some images that you bring to it. And we wondered, how good is Clip? Like, what does it know? What does it not know? Like, if we gave it an arbitrary drawing, right? Like said, hey, what does an upside down dinosaur look like? Would it have a concept of those sorts of prompts? And so we, some of the Roboflow team said, okay, let's have like a little hackathon and we'll build a game out of this new model to understand what it can and can't do. And so Paint was born out of sort of a weekend experience that Brad, who's on the call, is of course instrumental in building as well. And it blew up. Like the internet loves it. So in the first week, it had a little over 100,000 submissions. It was on the front page of a subreddit. It was on the front page of something called Hacker News. And people have really enjoyed sort of just playing this kind of like silly game of sorts. Recently, about I think 4 weeks ago, an Italian YouTuber who has like millions of subscribers posted a video of her playing Paint on her YouTube channel. And so Paint is huge in Italy. Like tons of Italians love playing Paint.wtf. And we left it live. Like it requires basically very little to no maintenance from us. It is a game that people are finding value in and enjoying playing. It is a demonstration of us trying out cutting edge sorts of tools and technologies. It really resonates with the people that we try to attract and hire, which are builders who are curious, trying out new technologies. So it's kind of an interesting like recruiting tool in that sense. And in terms of like Roboflow core business, it really has nothing overlapping. In fact, we even thought about like trying to sell it because we're like, we don't want to get too distracted by this. We need to focus on our developer tools and not get too focused by Paint. So that's what it is. It's an AI sandwich. That's a really fun game to play that the Roboflow team built to try out new technologies.
Very nice. Do we have any other questions from anyone else before I ask our traditional final question?
So, Joseph, if I can ask, now that you've got this probably data set of millions of annotations of pictures to pictures, have you considered going the other way around of writing AIs to go from, I give it a description of the picture and it gives me a cartoon for it?
I love that question. In fact, users of Paint have already started doing that and using generative models to almost hack the way that Paint does its judgments. So this gets kind of in the weeds, but someone discovered that you can use, I think it was BigGAN, for generating the illustrations that best resonate with the AI judge of Paint. And so they've kind of like hacked the system for like presenting the ideal image of what the system thinks an upside down dinosaur looks like, or what the system thinks a bumblebee that loves capitalism looks like. And so while we haven't experimented with that, when you have a product that like the internet, hundreds of thousands of people discover, inevitably people are interested in finding the bounds of what it can and can't do. And people have done exactly what you described, and it's been really impressive. Which, by the way, is one of the reasons we built it, right? Is we just wanted to see like, how does this inspire others? What are like edge cases? What like, will people try all these sorts of different ideas? I can pull I'll make a note to pull the link of that for you, of someone doing the reverse engineering of Paint.
Thank you.
Nice. So as we are starting to run out of time, we always have a traditional final question here at 1 Million Cups Iowa City. What can we as the community do to help you?
Yeah, I really appreciate that. We are deeply invested in improving both the Iowa startup scene and more broadly. And so right now, we're actively hiring, and if you have talented folks that you want to, flag and send our way for design, software engineering, and sales, and as I mentioned, wildcard, please do make them aware of kind of what we're working on. As I mentioned, that's roboflow.com/careers. And then if there's ways that, of course, we can help companies that come to mind. As I mentioned, we've done some work in Iowa City with Telefarm and Cardinal Health. We'd like to work more closely with other companies that have large presence across the state. like Vermeer or John Deere or places like that. So supporting other Iowa-based companies is something that we're excited to do. So I welcome certainly warm introductions or ideas around companies like that. So anything from talent to being able to help others use vision in their everyday are ways that we would love to be mutually beneficial.
Nice. And what's the best way for people to get in contact with you after the show is over today?
Joseph@roboflow.com.
Very nice. Thank you so much. I've learned a ton. I hope everyone else has learned a ton. I really want to thank you for taking time out of your day. I know you guys are busy over there, so